Firstly, this is a Big Bang model, meaning the universe has a starting point. But this beginning is not just a single big explosion. Everything we know about the universe, from star systems to dark matter and dark energy, has been acquired through decades of research and observation. We understand how the universe formed and expanded, but a recent discovery by the James Webb Space Telescope has left scientists astounded. This discovery overturns the current standard model of the universe's evolution and even questions one of the fundamental principles of physics. What is this discovery and why is it so significant? What does it mean for our cosmic model? And how is the scientific community reacting? Stay with us in this video as the image from the James Webb Telescope has shaken our understanding of cosmology. The evolution of the universe has always been of great importance to humanity. The desire to understand the vast world around us has led to the development of sciences like astronomy and cosmology. Through these fields, we have learned a great deal about the vast expanse of space and its many cosmic wonders. For instance, we have learned that the universe does not have a homogeneous structure, with some regions being denser than others. This is one of the factors that led scientists to believe in the Big Bang theory. The Big Bang theory is the widely accepted theory regarding the beginning of the universe. It states that the universe began with a massive explosion from a single point before expanding and cooling. Many findings, such as the cosmic microwave background, CMB, support this theory. The CMB is the remnant of the first light emitted after the birth of the universe. This glow from the aftermath of the Big Bang provides information about the state of the universe 13.8 billion years ago. Theories about the evolution of the universe have dramatically developed over the years. New discoveries are made with the inclusion of more complex instruments in the research process, requiring adjustments to existing theories or the creation of new ones. However, when unexplained sudden events occur in the universe, they can be confusing. The scientific community is questioning whether there is an unknown force in the universe, or if we have been wrong from the beginning. As you well know, the James Webb Telescope discovered such an event. This revolutionary telescope of 21st century cosmology has emerged as an extraordinary tool. Not only has it provided clear images of space beyond our planet, but it has also allowed us to look deeper into the cosmos. The James Webb Telescope was designed to observe the universe in greater detail than ever before. By searching for and studying stars and galaxies formed immediately after the Big Bang, it has provided data that helps us better understand how stars and planets evolve. This data has given scientists insights into how they can develop or expand the Big Bang theory. The ability to explore and introduce other concepts like dark matter and phenomena such as the universe's expansion with dark energy are fundamental elements supporting the Big Bang theory. For example, the theory of universal expansion shows that the universe is constantly expanding. This means galaxies and galaxy clusters are continuously moving away from each other. It is believed this has been happening since the birth of the universe 13 billion years ago. As the universe expands, more stars and galaxies are born. The force behind this expansion is thought to be dark energy, and it is also accepted that there is an invisible matter in the universe called dark matter. Over the years, various methods have been developed to measure or detect dark matter in the universe, but no real method has been fully established. Therefore, astronomers use various imaging techniques to calculate the amount of dark matter in a particular region. Gravitational lensing also aids this process. Gravitational lensing is a phenomenon that explains how massive objects in the universe distort space. This causes the light passing around them to bend. The bending of space by galaxies and galaxy clusters, and the bending of light from a distant source under these lensing effects, allows scientists to map dark matter. Through this, you can see how important the James Webb Telescope is for humanity. Without it, we could never bring many of the fundamental theories of the cosmos to life. Without the James Webb Telescope, we would never have been able to obtain the beautiful images of distant stars and galaxies that we have today. This has greatly benefited the scientific community. The James Webb Telescope continues to make significant discoveries recently. One of these discoveries was the planet-like objects captured in the Orion Nebula. The Orion Nebula is a popular nebula in the Milky Way, depicted as a sword in the constellation Orion. Previous studies had never revealed any objects hidden within this cosmic cloud of dust and gas until JWST came into play. This is just one of many new and interesting discoveries JWST has uncovered. However, there is another discovery that is not only interesting, but also quite disturbing. This recent discovery, depicted in JWST's images, could shake our entire understanding of cosmology. The truth is, scientists are beginning to think that the Big Bang theory might be wrong. So what exactly did James Webb discover, and why does this discovery shake the very foundations of our cosmology and astronomy? Recently, James Webb revealed that over 771 trillion solar systems suddenly disappeared from our universe. This means over 771 trillion stars and their associated planets vanished. This is not normal and has never been observed before. Moreover, this event contradicts one of the most fundamental laws of physics, the law of conservation of matter, which states that mass cannot be created or destroyed, only transformed from one form to another. Studies of the universe have so far been based on such laws, and scientists are struggling to explain how such a massive amount of stars and planets could disappear from the universe. Did they vanish, or did they just become invisible? Some experts have proposed a plausible theory. This theory suggests that the disappearance of these solar systems is actually the final stage of their mass transformation. In other words, these stars and planets still exist, but in another form in the cosmos, and we cannot see them. The theory suggests that as stars age and can no longer retain their gas, they explode in a supernova, dispersing their mass into the universe. So what if a similar thing happened to these suddenly vanished solar systems? Most of the scientific community agrees that stars do not just disappear without at least a supernova, and that such a massive supernova event is impossible. Such a colossal event involving trillions of stars would not go unnoticed. Such a massive event would ripple through the entire universe, and even our Milky Way galaxy would be affected by this ripple effect. Therefore, this initial theory is being set aside. However, another theory sheds a different light on the situation. This theory suggests that black holes might be responsible for the sudden disappearance of these stars. Black holes are powerful gravitational regions in space that absorb matter and light. Anything approaching a black hole, even an entire star, can be swallowed up by its immense gravity. However, in this scenario, it doesn't seem plausible that black holes could account for such a massive disappearance. We are talking about trillions of stars here. Could a black hole consume trillions of stars? This seems unlikely. Unless there are millions of black holes, this explanation doesn't make sense. This theory, which claims that black holes are behind this mysterious event, has led a team of scientists to turn their attention to history. Beatrice Verroel, a scientist at the Nordic Institute for Theoretical Physics in Sweden, is leading a unique project that hopes to solve this mystery. Named VASCO, this project involves scanning astronomical archives to find a star that existed in the night sky since the beginning of cosmology, but suddenly disappeared at some point. In other words, Roel and her team hope to find a similar example of a vanishing star. If such a star is found, scientists might be able to figure out why it disappeared and use that to explain the current observations. However, no such star has been found so far. The VASCO project has still generated great interest. Astronomers and other researchers believe that a star disappearing from the sky is possible, but may have been overlooked due to the vastness of the universe. Perhaps such a star was never cataloged. Nonetheless, Roll and her team are not giving up on the Vasco project. There is still a chance that a star could disappear from our skies without being noticed. Furthermore, astronomer Lear Aravi proposed that some stars could turn directly into black holes without going through the usual supernova process. Aravi mentioned a scenario in 2009 where a star transformed into a black hole. This star, at the end of its life cycle, suddenly collapsed into a black hole, and the event happened so quickly that scientists couldn't grasp the details of the process. Could a similar scenario be happening here? However, since no black holes have been detected in the locations of these star systems, the current data suggests that the stars have seemingly vanished into thin air. Therefore, it seems that there is another mystery here besides black holes. A civilization might create advanced technology to power their lives, and this technology could be thought of as a circular structure built around a star to harness its energy. Such a structure would turn the star into an energy generator or battery. However, the existence of Dyson spheres is still uncertain, and it is believed that there would need to be at least 1 billion civilizations to control 771 trillion stars simultaneously. This theory does not seem sufficient to explain the sudden disappearance of these stars. Scientists remain puzzled by this event, as it cannot be explained by current theories. But this is not the only disturbing discovery. In the distant void of the universe, some stars in the spiral galaxy NGC 5584, approximately 75 million light-years away, are pulsating in ways that do not fit our cosmological models. This discovery suggests that the universe is expanding faster than expected, contradicting our fundamental understanding of the universe. This brings us to the topic of the Hubble constant. The Hubble constant is a proportional constant that relates the velocities of galaxies to their distances and expresses the rate of expansion of the universe. It is named after Edwin Hubble, who demonstrated the linear relationship between the distance and speed of galaxies using large telescopes. Although Hubble introduced this constant by observing the expansion of the universe, the true value of the constant has been a subject of debate in the scientific community. Scientists use various methods to estimate the Hubble constant. For example, they might select a distant star in the Andromeda galaxy as a reference point and observe the distance between the Earth and this star over a year to determine the annual expansion rate of the universe. The value of the Hubble constant can also be determined through the cosmic microwave background, CMB. The CMB is the remnant of the first light emitted after the birth of the universe, and has a temperature. As the universe expands, the temperature of the CMB decreases. Scientists have discovered that the cooling of the CMB is directly related to the expansion of the universe. By measuring the cooling rate of 2 Kelvin of the CMB over a 10-year period, scientists can derive the value of the Hubble constant. However, these two methods have never yielded the same results, a situation known as the Hubble Tension. Scientists do not know why these two methods do not produce the same results. The latest discoveries by the James Webb Telescope suggest that both methods might have been wrong from the start, and that the universe is expanding much faster than expected. This is causing significant discomfort in the scientific community, as many discoveries made in recent years have required adjustments to our cosmic model to align with new data. According to the data, the revisions made back then seem necessary, but now in light of the latest discoveries, these revisions appear to be adjustments made to compensate for the gaps in the Big Bang theory. Scientists are seriously beginning to think that something might be seriously wrong. The standard cosmology model we use today is largely based on Edwin Hubble's groundbreaking discovery of universal expansion in 1929. Hubble proposed that the farther galaxies are from Earth, the faster they are receding, and that our universe is expanding uniformly in all directions. Other concepts like dark matter and dark energy were built on Hubble's theory, and various adjustments were made. One of these adjustments is the cosmic inflation theory. According to this theory, the universe expanded at an enormous speed in the first fraction of a second after the Big Bang, ensuring that the initial expansion was smooth and homogeneous. However, there were still voids in the universe. Some experts thought that such a sudden expansion could lead to the creation of other universes. Thus, the multiverse theory emerged. The multiverse theory suggests that there are infinite universes, and our universe is just one of them. However, it is not possible for us to see or reach these other universes. Cosmologists are dealing with many issues they are trying to clarify and correct regarding the evolution of our universe. But this new revelation from the James Webb Telescope could be the final evidence needed to confirm that the Big Bang theory and all the other adjustments we've made to the standard cosmic model are wrong. Many experts in the scientific community believe that it is time to break away from the standard model and start reanalyzing everything as the cosmic model is developed. There were no scientific tools with advanced technology like James Webb, so wouldn't it be wise to abandon these old theories and develop a new theory from scratch with the James Webb Telescope? Many astronomers and cosmologists believe that this would be wise. However, trying to develop something that the entire scientific community can agree on requires a lot of work. Moreover, it is not easy to start searching for new answers by putting aside our fundamental laws of physics. Therefore, even if the Big Bang theory is wrong, the scientific community will have to stick with it until a better, more advanced, and universally accepted model replaces it. Thank you for watching another episode of Voyager. Don't forget to click the video on your screen for more mind-blowing videos about space.